winter night.
We are beginning a new unit on factoring, and so if you would take out your notes, we could get started. There are different methods to factor polynomials. We have the greatest common factor, we have the difference of perfect squares, factoring a trinomial, and multi-step factoring, which combines a mixed variation of all of these methods. Tonight we're going to take a look at the greatest common factor. So let's go back and take a look at the greatest common factor. By the time we're through, the student will be able to find the prime factorization of a number, but also find the greatest common factor for a set of monomials. Go back and think again about what constitutes a prime number. A prime number is a number that can only be divided by 1 in itself. A composite number is a number greater than 1 that is not prime. So are the following prime or composite? 37. It's prime. 51. Tricky. It's actually composite. So find the prime factorization of the next 3 numbers on the page there. 84, negative 210, and 45, a squared b to the third. All we're doing is breaking this down into the prime components. So for 84, you should have gotten 2 squared times 3 times 7. For negative 210, you would have gotten negative 1 times 2 times 3 times 5 times 7. When we get to the monomial, you're again breaking it down. Now I realize that the variables are in exponent form and I'm asking you to break them down. That's just to see the pattern that is going to emerge between numbers and variables. Alright, so moving forward, what really is the greatest common factor? It is the largest number that can divide into all of the numbers. So what is the greatest common factor of 42 and 60? We start by writing the prime factorization and then we find what they have in common. We multiply that out, and it's 6. 6 is the largest number that can go into 42 and 60. Now, I know many of you can do this in your head. The reason we're explaining it is, again, because we're going to be working with expressions, not just numbers. So we're taking a really close look at greatest common factor. What is the largest numerical factor of 40 and 48? What is the common factor of a squared b and ab to the fourth? Well, if we break all of this down and circle the common things, we're going to get 8ab. Now I know you can do that just by looking at it, and hopefully you're seeing the pattern here. What is the GCF of 48 a to the fourth b to the 8th and 72 a cubed b to the fourth? Drum roll please. And the answer is number 4, 24 a cubed b to the fourth. To factor using the GCF, we first find the GCF, then we divide each term by the GCF, and finally check your answers by distributing. So let's factor 25a squared and 15a. First thing is, find the GCF. The GCF is 5a. Then we divide both of those terms by 5a, and we bring that 5a out into the front. 5a times what plus what will give us 25a squared plus 15a? The answer is, if we divide that out, we get 5a plus 3. So try the next one on your own and see if you can come back and have the same answer that I have. The GCF is 28ab. We divide each term by the GCF, and we are left with a plus 2c squared. Now, focus on this next comment that I'm going to make. Notice the a plus 2c squared. These terms do not have anything in common with one another. There's no c or even coefficient to the a term, and there is no a in the second term. You need to be clear that they don't have anything in common, because if they do have something in common, you missed a factor. And then you can check your answer by distributing. So let's just try a couple more examples together and discuss this. Consider 10x squared y cubed and 15x y squared. Well, the greatest common factor is, what do you think? The largest factor of 10 and 15 is 5. The highest power of x that's contained in both terms is x. That's one of the things you can think about when we have common letters for variables. Look for the highest power that's contained in both. And the highest power of y that's contained in both would be y squared. So the greatest common factor would be 5xy squared. Factor 4x plus 8y. Well, the largest integer that would divide evenly into 4 and 8 would be 4. They do not have any common variables. The factorization of that would be 4 times the quantity x plus 2y. Try the last one. Factor 15x squared y cubed plus 10xy squared. Well, the largest integer that divides into both is 5. The largest power of x that's in both is x. The largest power of y that's in both is y squared. And so we would then divide by the GCF of 5xy squared, and we would get 5xy squared times the quantity 3xy plus 2. How are we doing? We have some practice problems, so go ahead and complete those next 5 and come back and check your answers. That's the first part, just finding the GCF. Now I'd like you to go ahead and factor each polynomial. So now you're going to show the result when those polynomials are divided by the GCF. And here are the answers to that section. Check your answers, and we'll get more practice with this tomorrow. Have a great night.